All right, let's dive right into this explainer. We're going to solve a mystery that is literally sitting in the palm of your hand right now. Think about it. You tap a screen, type a few keys, and instantly a machine hands you an answer, a map, or a perfectly translated sentence. But what actually happens inside that black box of a computer after you give it information and before it gives you that final result? Today, we are popping the lid off that box to see exactly how those digital gears turn. To get there, we'll break things down into 4 quick parts: what processing actually is, 4 common types of it, how apps combine those types, and finally, what lies beyond the basics. So, part 1. What exactly is processing? Well, we all know computers take input and spit out output, right? But the real magic? That happens in the invisible middle step. The machine actually has to work with the data. That thinking work, taking raw input and turning it into something meaningful, is what we call processing. Think of it as the ultimate core flow of computing. Input flows in, processing happens, and output comes out. Take a basic calculator. You punch in numbers, that's your input. The instant, invisible math it does, that's the processing. And the final answer on the screen is your output. This exact same loop is absolutely everywhere. Imagine a super simple birthday app. You input your birth date, the app then acts kind of like a bouncer. It processes that input by comparing it to today's actual calendar date. If it's a match, it outputs a big, happy birthday. If not, you just get a standard screen. That quick little comparison is processing in action. Moving on to part 2, let's look at the 4 common processing types that act as the pillars for your favorite apps. First up, we've got if-then decisions. It's basically the ultimate digital ultimatum. The rule is simple. If a certain condition is true, then the computer takes a specific action. You know, if your video game character grabs a coin, then bump up the score. If they lose all their health, boom, game over. We see this play out all the time in everyday stuff, like a weather app. The programmer sets up a rule. If the input temperature is above 80 degrees, the output tells you it is hot. On the flip side, if the temp drops below 50 degrees, the app triggers a totally different rule and outputs it is cold. It's not the computer making a judgment call, it's just strictly executing those if-then rules programmed into it. The second big type is comparing. This is when the computer checks how different pieces of data relate to one another. Are they exactly the same? Is one bigger than the other? Think about a number guessing game where the secret number is 60. You guess 75. The computer compares the two and instantly tells you, too high. And hey, computers don't just compare numbers. They can compare words, dates, colors, you name it. The perfect example is the lock screen on your device. Every single time you log in, the system takes the password you just typed and compares it, character by character, with the secure info stored in its database. Exact match? You're in. Our third pillar is finding a match, or searching. Honestly, you can think of this as comparing on steroids. The computer takes your input and rapidly fires it against thousands or even millions of stored items at warp speed until it gets a hit. You probably trigger this dozens of times a day. When you search for a video online, the site processes your typed keywords against millions of titles and tags to give you that perfectly curated list. Or think of one of those famous birthdays apps. It searches a massive database to find a historical figure born on the exact same day you were. The fourth common type is counting. It's exactly what it sounds like, keeping a strict tally of how many times an event happens, or tracking how many items meet a specific condition. It's just simple math, but done at lightning speed with a memory that literally never fails. We rely on counting for pretty much anything that tracks our progress. Your smartwatch constantly processes input to count your daily steps. A travel app tallies up the countries you visited. And obviously, gaming relies heavily on counting points and lives to keep the action moving. Okay, part 3. This is where things get really cool. How apps combine these processing types. Because, let's be real, apps rarely just do one single thing. They are massive multitaskers. Remember that simple number guessing game we just talked about? It's actually doing a lot at once. It's comparing your guess to the secret number, using if-then rules to tell you if you're close, and silently counting your total attempts in the background to give you a final score. Or take an app that recommends the best city for you to live in. You put in your preferences for weather and scenery. Instantly, the app orchestrates this whole symphony of processing. It searches a huge database, compares those cities against your checklist, and uses if-then rules to filter out the bad fits. The result? A perfectly tailored recommendation just for you. Which brings us to our final section,
beyond the basics.
While those four pillars are super common, the processing power of modern computers extends way, way beyond them. Programmers design instructions that let computers do mind-blowing things, from translating entirely different languages on the fly and resizing massive images, to recognizing the subtle tone of your voice and detecting hidden patterns that a human eye would never even catch.
But here's the crazy part. No matter how advanced it gets, that core loop is always identical. A navigation app processes live traffic data to give you driving directions. A translation app processes complex grammar to give you a new sentence. They are vastly different tasks, but they use the exact same fundamental computing structure. As we wrap up this explainer, the absolute most vital takeaway is this. Yes, processing is the thinking work that bridges input and output. But computers, they don't do this on their own. They aren't sentient. Every single brilliant comparison, search, and if-then decision is the direct result of a human programmer designing the exact instructions that the machine must follow. Understanding these hidden mechanics completely changes how you look at the devices you use every single day. So I want to leave you with a quick challenge. The very next time you open an app on your phone, whether it's a game, a map, or your social feed, just pause for a second and ask yourself three things. What is the exact input here? How is the computer processing that info behind the scenes? And what is the file output? If you can answer those three questions, you've basically cracked the code of how the digital world operates.